Hello and welcome to a short video presentation on Libero SoC FPGA design tool. In this presentation, we are going to demonstrate how to apply the Netlist attributes using NDC constraint file. Netlist attributes. NDC constraint file was introduced in Libero SoC version 11.7 as part of enhanced constraint flow. There are two types of constraints: NDC constraint, which will be discussed in this presentation, FDC constraint. A separate video will be available on this in our website. These are text only files. You can use Libero's default text editor to create these constraints file. Now let's talk about NDC constraint file. NDC constraints are non-timing constraints. These are used for I/O register combining and preserving instances from getting optimized by the compiler. And you need to apply these constraints during synthesis process of your design flow. There are two NDC constraints: set_IOFF, which combines embedded I/O registers at the I/O buffer level to achieve better I/O timing; set_preserve, which sets a preserve property on instances to prevent compiler from combining them. Both constraints are supported in SmartFusion 2, Igloo 2, and RTG4 devices. PolarFire devices only support set_preserve constraint. Because I/O register combining is available in layout option, you just need to apply proper timing constraint in that case. Now let's see how to apply NDC constraints in the Libero tool flow. As you can see in this GUI, you can create new NDC constraint file. Also, you can import or link an existing constraint file. Make sure to check the synthesis box. Now let's do a short software demo about NDC constraint file. Here is a small design. It has 3 flip-flops. We are going to apply set_IOFF NDC constraint on the Q port of the last flip-flop here, the FN1_2. We are expecting this flip-flop will be combined with the output register of the I/O module. We are also inserting an inverter in the clock line to demonstrate set_preserve constraint. Now come to design flow window. Double click on manage constraint, and manage constraint manager menu will pop up. Click on Netlist attribute tab, click new and select NDC and provide a name for the file and enter the constraint. Each I/O module has 3 embedded registers: input, output, and enable register. Since we are combining the output register, the argument would be yes for this register and no for the other 2 register. We are going to save this file, and we are going to now come to constraint manager menu, check this box for the synthesis, and run synthesis. Synthesis completed. We are now going to check whether I/O register combining worked. So we're going to double click on Netlist viewer. Now let's click on flat post compile and zoom into the area of interest. This is the flip-flop DFN1 underscore 2. We implemented set underscore IOFF constraint on the on this flip-flop. As you can see, this flip-flop has been combined with the IO module, and then we have a different IO module name compared to the other two flip-flops. They are implemented as regular post-compile macro, SLE macro. Also, we're going to check the clock line for the DFN1 underscore 2 flip-flop. We had an inverter in the clock line. As you can see, the inverter has been optimized. And to maintain the logic, the clock polarity has been reversed. It has a bubble right now. So we can see that set underscore IOFF, the NDC constraint, has been successfully implemented after the synthesis process. We're now going to close the Netlist viewer and look into set underscore preserve NDC constraint. Now let's come back to constraint manager. This time we're going to link an existing file. Use this link menu that has both set underscore IOFF and set underscore preserve constraint. So click on link. We're now going to find the constraint, the NDC constraint file in a different location so that we can link it to the project. This constraint folder here, it is in different destination. We double click on this folder and select NDC type and grab this file. As you can see, this file is linked into our project. Just to make sure that we have both the constraint, double click this file, and as you can see, we have the constraint for the set underscore IOFF, the constraint that we have shown you before, and also the set underscore preserve constraint for the inverter. We want to stop optimization of this inverter. So come back to constraint manager. This time we select the new linked NDC file. We come back to design flow and resynthesize the design. Synthesis process completed. Like before, we're going to check whether the constraints have been implemented correctly. So click on Netlist viewer. Same thing, click on flat post compile view and zoom in. Like before, we can see the DFN1 underscore 2 flip-flop. It has been combined with the IO register, and you can see different IO macro. And the other two flip-flop, they are, as shown before, they are implemented as SLE macro. Now let's concentrate on the clock line of the DFN1 underscore 2 flip-flop. We had the inverter inserted in the clock line. And now you can see that inverter is still present in the clock line. That means this inverter did not get optimized. So we can see here that set underscore preserve constraint has been successfully implemented. This concludes our software demo. In summary, Libero's enhanced constraint flow provides an efficient way to apply netlist attributes, which leverages the architectural features of the microsemi devices and ensures a robust netlist from your design. For more videos and collaterals, visit Libero SOC tool documentation page of the microsemi website. This concludes the presentation on NDC constant file. Thanks for watching this video.